Decisions, decisions. It's time for our C++ console programs to start thinking. That's right, let's learn some if statements. This is the first in a series of videos on C++ if statements. Come on and take a look. So now with my C++ examples, we're going to step it up a little bit. I've got some examples on making decisions in my program. And I've got a series of 4 examples. Each one gets a little more complex. The first 2 aren't too bad. This is just some simple if statements. And this is doing pretty much the same thing but with strings. Then I add the alternative, the if-else statement. So we're going to do something if a condition is true, and we're going to do something else if it's false. And then finally, the 4th example, I'm going to be putting a if statement inside of an if statement, and that is known as a nested if statement. Now we can do these by running the Visual Studio Community Edition. If I go inside here, these are Visual Studio Community Editions, and you can see it's a whole bunch of subfolders, but here's my solution that I need to double click on to launch this project. If you want to know how to create a console project in C++, I have a video which I will link to in the description and in this video somewhere up near the top about now. The other thing you can do is you can use the online C++ compiler, which I have also done a video on, and it's just a matter of putting your code in it. So here is my code for C++ simple if statements, and if I was to grab this entire source code, and I'll just copy it, and if I was to go to the online C++ compiler, which I already have up, it's www.onlinegdb.com, and you want to make sure that when you go in here you choose C++ for your language, and then I can simply select all this code here, the starting code, and paste my code in its place, and I can run it here just the same as I can run it in Visual Studio. It's C++ console code. It works in virtually any compiler. Now I want to do this in Visual Studio Community Edition because its debugging features are more robust, so I can show you what the program's doing. So first of all, if I just run the program without any breakpoints, without any debugging, it's going to run it. It's going to pop up a window on the other screen. If I bring that window on here, it says, please enter the temperature. I'll say it's 90 degrees. Please enter the humidity. I'll say it's 90 degrees humidity. So it says, it is hot and not a nice day. Wish it was a nice day. It is sticky and not a nice day. So that's the messages it's outputting, and then I can press any key to close the window. So if I come down and look at the code, it's a standard C++ console application. I have my #include for IO stream. I have using namespace standard, and I have my main program where I have declared 2 variables. I'm going to be inputting temperature and humidity, and my output is going to be a message saying whether it's a nice day or not. These variables that I'm inputting into, I named one temp for temperature. It's a floating point variable. It can hold a floating point number. And then I've got humidity. So then I'm going to do a cout. Please enter the temperature. Cin into temp so the user can type into temperature. Then they can do the same thing with humidity. And then I'm going to go into a series of if statements. So this if statement, the format of an if statement has to be if in lowercase, open parenthesis, close parenthesis, and inside the parentheses you have a condition. So in this case, I am comparing the value of temp, whatever the user typed in, to see if it is greater than or equal to 90. If this condition is true, it will do these 2 lines of code. If this condition is false, it'll jump down here and go into the second if statement. And then in the second if statement, if humidity is greater than or equal to 70, it's going to output a message that says sure is sticky. So let's look at a couple gotchas with an if statement. If I did not use this brace, everything that's between this open brace and this close brace is the code that gets run when this is true. And the brace makes a whole bunch of statements as far as the compiler is concerned into one statement that starts here and here. So if this if statement is true, pardon the pun, if, then these two will be run. Now, a common mistake I could make is if I didn't have these curly braces at all, now it looks like if the temperature is greater than or equal to 90, it's going to do these two lines of code. But in reality, the if statement starts right here and ends right there. So if it's greater than 90, it's going to say it's hot and not a nice day. It is always, no matter what, going to do this because this is not part of the if statement. In fact, it really should be indented like that, just so visually you know that. But what I prefer to do is always, even if it's one line of code, I prefer to use the braces. Let me get this cleaned up so it's legal code again. There we go. And then this stuff right here, I can click, drag, select it, and hit the tab key to indent it. So now it's very clear that if this condition is true, it's going to do these two couts. You see right here, I only have one cout. So legally, I could do this. I could leave that off. Because if this condition is true, it will do the very next statement, but that semicolon right there marks the end of it. Your best habit as a C++ programmer is to always use the curly braces, just so that if you ever go back to add more code to the true part of an if statement, you don't shoot yourself in the foot by thinking the code is part of the if statement, but it's not. So now what I want to do is step through the program in the debugger. And the part we're really interested in is these if statements. So I'm going to come to line 28 here and click in the gray bar, and it's going to put a red circle, and that is a breakpoint. It will pause my program before it does this if statement. All right, so save all is always a good habit. I can look to see if I have any typos in my code by going to the build menu and telling it to build my solution. And down here it says build succeeded, 0 failed, 0 up to date, 0 skipped. So it compiled my code. I have no syntax errors. So now I'm going to run it by hitting the green triangle. It's going to run my program to the point. It's running right now, asking me to enter the temperature. So let's do that same temperature I did, which was 90. And let's do the same humidity, which is 90. And right now my program has paused on line 28. If I hold my mouse over temp, doesn't matter where I hold it over temp, it shows me that the current value of temp is 90. And it's a floating point number, so it's 90 point blah, 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 a bunch of zeros. Humidity, I happen to have typed in a 90. So it also has a value of 90, but now I want to run this one line of code. I don't want to continue. I'm not going to hit the continue button. That would run my program to completion. But if I come up here to the toolbar and say step over, the shortcut key for this is F10. It will run one line of code. So it's going to say if temp is greater than or equal to 90, that is a true statement. So you can now see it is inside the if statement. And it's going to, I'll hit F10, F10. So it just did those two couts. So now I can see it said, it's hot and not a nice day. Wish it was a nice day. So now we're paused just before this if statement. So if I hit step over, it ran this one. Humidity is greater than 90. This condition is true. So now it's going to do this cout as soon as I say step over. And then that is the program. It has done all of its outputs, and I could just tell it to continue. And then what it's going to do is say press any key to close this window. So it ran the program to completion. Now, another thing you really have to watch out for in C++ if statements is the equal to operator. Now, I wouldn't want to do this, but if I wanted to say if temp is equal to 90.25, okay, I'm making a very common newbie beginner mistake, and we all make this. I even make it sometimes as an experienced C++ programmer. I just get in a hurry. But when you say single equal sign, you are not comparing temp to 90.25. You are writing an assignment statement. What I'm saying is put 90.25 into temp. And since the value of temp is non-zero, it's going to be true and it's going to do that. Now, most likely, if I put a 0 into temp, then this would be false because 0 is false. Now, what you want to do, if you're trying to compare equal to, you have to say equal equal. So single equal sign is assignment operator. Double equal sign is compare temp to 90.25. So if I ran the program right now, and I will be careful to type in 90.25 for the temperature, and let's say 50 for the humidity. So right now, is 90.25 equal to 90.25? I'll say step over, and it's true, so it's going to print out those messages. And then is humidity greater than or equal to 70? That's false, so it is going to skip over. As you can see, it skipped over that if statement. Now, I'll just tell it to continue right now. Finish the program. Now, I don't want to say equal equal. What I want to say is greater than or equal to. Okay, and you can imagine that I could say, instead of saying greater than or equal to, I could say less than or equal to. I could say greater than 90. I could say less than 90. I can pick all those different iterations. The only one you got to watch out for is not equal. That is not equal to. And if you want to compare for equal, it's equal equal. So, but we want greater than or equal to 90 because that's our definition of hot in Texas. Anything below 90 degrees is not hot. So if we're done debugging, I can hit the red circle and get rid of my breakpoint. And right now, you see this yellow line right here. That means this change has not been saved. So I can hit my save all, and it says, here's the recent changes you've made, but they have been saved. So that is simple if statements. What I want to do next is switch over to doing the same sort of thing, but with strings. So I'm going to close this project, and I can hit spacebar to close that window. And let's go back up a level and say C++ comparing strings. I'll go into the folder of the project. I will launch the project solution. It will launch Visual Studio. But here is my string project. So in this project, I'm going to be inputting two strings, and then I'm just going to output which one is the largest. So we don't need any extra libraries for C++. We just have to declare, I'm just declaring three string variables: string, string1, string, string2, and string largest. I'm going to get the user to type in string1 and string2, and then here is my if statement. If string1 is greater than string2, largest equals string1, else largest equals string2. So if this condition is true, string1's the largest. Otherwise, string2 must be the largest. So I'm not checking for equal to, so here's an example of checking for equal to. If string1 is equal to string2, I'm building a more complex message that says string1 and string2 are equal, and then down here my last cout just says largest string, and then I print out the value of largest. So if I run the program, I'll just run the program normally here. It will compile it and look for typos, and then it'll come on the screen, and I'll enter Joe Bob for string 1 and Zeb for string 2. So it outputted largest string is Zeb, because Zeb comes after Joe Bob in the alphabet. So now I'll show you an interesting thing. If I was to type in Joe Bob for string 1, but lowercase Joe Bob for string 2, which one's greater? Well, lowercase Joe Bob is greater because the number code that is used to store J on the computer is a larger number than the number code for capital J. Now, otherwise, it kind of works like you expect in the dictionary. So if I say a and an, the largest of the two strings is the longer of the two strings, an. All right, so let's step through it in the debugger again. I'm going to put a breakpoint on line 29, start my program, and I will use my standard data set of Joe Bob and Zeb. So now it has paused my program just before running this line of code. You can see that string 1 has the value of Joe Bob, string 2 has a value of Zeb. If I single step my code, it jumped to the else, so this is false, so it's going to put Zeb into largest. Then it's going to see if the two are equal. They are not, so it skips over it down to the cout, and then it's going to print out my message telling me that the largest of those two strings is Zeb. Now once I've done that, I can just hit continue and my program will run to a finish, and I can hit spacebar to close this window. So what happens in C++ and in most programming languages when you compare a string to a string is it gets the first character of that string, whatever value it is. In the case I had before, it was Joe Bob, looks at the number code for that capital J, and then compares that to the number code of the first letter of the second string. If they're tied, then it goes to the second letter of both strings and compares the number codes of those letters. And if they're tied, it goes to the third letter and compares the codes until the tie is broken. And lowercase letters have a higher number code than uppercase letters. They go A through Z in order, like a capital A is a 65, a capital B is a 66, but a lowercase a is much higher than all the capital letters, so that would be considered larger than the lowercase letters would be considered larger than the uppercase letters, and that's just the way they decided to set up the number codes for the ASCII system, which is the numbering system they use for characters on the keyboard. But this is basically how it works. Now, once again, if you just had your source code, I can select it here and copy it, and if I was to go to my online C++ compiler and paste it in and run it, it should run just fine. Enter string 1, we'll say AAAB. Enter string 2, AAAA. And of course, AAAB is larger because they were tied on the first three characters. But the B has a larger number code than the letter A, and B comes after A in the alphabet, as you would expect. So you can see the code runs both ways in both compilers, and I do have a video that shows you how to create a console project in Visual Studio, which is a little bit involved, and how to download Visual Studio Community Edition, and then how to use the online GDB compiler. But this is my first two decision statement, if statement videos. Well, two examples in one video. So take care. If you enjoyed these videos and you want to get notification of new videos, please like and subscribe. Thanks a lot.